It has a calculation part of the theory part of the course. So we'll be brushing through the two different parts of the course in today's revision, starting with the theoretical part. Then we move through the calculation part of the course. With this being said, let's stop straight into it. We'll go straight into it. For those of us who are not aware of the exam keynote for this course, this leads to also request for it is highly essential and it's recommended you use one in preparing for exams. To get the keynote or to become a member of one of our private class where we walk through all the classes throughout the semester, you can reach out to me on www.tutoril.com and use the WhatsApp icon on our website. It takes you, enables you to send me a direct message on WhatsApp. Thank you. Now we have MTH101. Okay. Now the very first question we are taking. Now it says here, a dash is a collection. A dash is said to be the collection of elements. All right. A dash is said to be a collection of elements. Okay. A dash is said to be a collection. Okay. A collection of elements. So let me add a question on the board. A dash is seen as a collection of elements. Okay, so we have our question 1. So who's giving us an answer to that? As a dash of, if I have it on the board. Yes, a set. Basically just an abbreviated definition. Right, we are talking about this in full. We are talking about a collection of elements, data, and some other objects. A collection. Not what I say, collection. Yes, it's a set. Call it set theory. Now let's take the next question. Now we have an empty set, otherwise an empty set is otherwise known as a dash set. An empty set is otherwise known as a dash set. An empty set is otherwise known as a dash set. Yeah. An empty set is otherwise known as a null set. A null set. Yes. Now we also have a dash set contains bounded elements. A dash set, all right, a dash set contains A dash set contains, okay, bounded elements. Bounded elements. Okay, a dash set contains bounded elements, e.g., all states in the country Nigeria. All right, so we have that. A dash set contains okay, a finite, yes, a finite set, a finite set contains all elements, bounded elements, I mean to say. Now we have question 4. Now, it says here that two sets are said to be equivalent. Two sets are said to be equivalent if their dash numbers are equal. Are said to be equivalent, all right, if their dash just a moment, I'm trying to see if I can switch something else. Yeah, this is what I'm looking for. Are said to be equivalent if their dash numbers are equal. Are equal. Are we together? Okay, we have a question. Yes, wonderful. If they are cardinal numbers, cardinal equal. Wonderful. Cardinal numbers are equal. Okay. Now we have question 5. We have now we have question 5. Just a moment. Now we have this symbol represents what? All right. The symbol represents what? Okay. Yes, it represents a set. Okay. And the alphabet figures what of you in A of the elements, or they are called elements. Okay, so we have question 6. Theory represents dash. Okay, this symbol in set theory represents dash. Symbol, it's wonderful. It represents what we call intersection. Intersection. Wonderful. It represents intersection. Okay, I'm supposed to bring my for this. Set intersection. Now let's take one or two on the calculation part of the course. Now, let's take this question. It says, let set B equals 1, 2, 3, and set A equals 4, 5, 6. Fine. All right. B. All right. Union A. So what are we looking at? Simple. B union is simply telling us that set B here is gotten from a union. Likewise, set A here is gotten from a union. Therefore, the combination of these two makes the union, which is 1, 2, 3, 4, 5, 6. And we have, let's say equals 1, 2, 3. Set B equals 3, 4, 5. 9. Okay. A intersection B. I think I should switch this. Yeah, something like this. A intersection B. Then answer becomes that intersection. What are the elements, or what is the elements that can be found both in A and in B? It means that what are the elements that can be found in A, in set A and set B? That is the intersection. Now let's take the next question. Now we have question 8. So we have set A equals 1, 2, 3. And set B equals all right, equals 312. So now, what is A subset B? Let's have 5 here. So now, A subset B have A subset B, therefore, is we have 3. Now let's just take it like this. 3. No, let's arrange it properly. Sorry. We have 1, 2, and 3. Why? Because these are, okay, what can be found in B. All right. And if you remove, now let's take it this way. Let's take it under this question. We can also have it like this. A equals 2, 4, 5. Meaning that the complete set A here can be found or is found in B. That is what makes it a subset. Okay? If this is B now, so we have 5, 6, 7, 2, and we have 4 and 8. So now, A subset B will be we have, which one comes? We have 2. No, we have 5 first. We have 5, then comes 2, and there goes 4. So we have that as that. And we're going to call it a wrap here for today. There's a lot more in the keynote, all right? So we can always request for that. See all the subsequent tutorial, and do have a wonderful evening. Bye for now.